So during this session, we're going to discuss how Druid's dedicated 4G networks enable really good quality enterprise comms and also digital automation solutions over secure and resilient mobile networks. So first, introductions. Anyone want to have a go at pronouncing my first name? No. Go on. Wow, my goodness, perfect. I don't even have to do the whole tiger, but without the R bit. Very good. Well done, well done. So I've over 20 years experience both business to business and business to end user. So obviously that gives me an advantage with channel partners like Britannic. I understand how they work. But more importantly, like we were saying this morning, I'm interested in the stories. I'm Irish, of course. I love telling stories. But I'm interested in your stories and what you want to achieve with networks, really. And that's where the whole driving mobile technology innovation bit comes in. I'm interested in seeing what we can do with mobiles, tablets, etc., and how we can deliver on what you need to do in your businesses. So Druid Software was founded in 2001. We're a development company based in Dublin. We're focused on cellular core network development. And we deliver private mobile networks to enterprises globally, always through partners. And we're market leaders in private cellular network deployments. How many of you have heard of a private network before, a private cellular network? Brand new? Okay. So our model is firstly through distributors. And we signed a global OEM agreement with Mytel back in 2012, which is very exciting. We also have a national distributor here, Icon PLC, who have a lot of experience with Spectralink, DECT, and Wi-Fi, and now our solutions. But more importantly, we're with Britannic here today. They're our reseller and systems integrator, and they're letting you guys know about what we're doing in the rest of the world and here with private networks. As you just said, you may not have even heard of a private cellular network before, but it's enabling the use of the mobile and smartphone you all have in your pockets at the moment. And then, of course, yourselves, the end users. We often go out with Britannic. We're here to support them commercially and technically, especially with the first couple of projects, etc. And then globally, I mentioned Mytel already there. So we're busy with Mytel in Asia Pacific, North America, Europe. We have some of our biggest hospitals with Mytel in Europe, delivering over 10 million calls a year, for example. Also some work with Cisco, with the Small Cells Group. Vodafone Netherlands started reselling our products last year, along with their enterprise communication systems, etc. Panasonic, we deal with the Panasonic Corporation. They're a massive company in both Tokyo and California. Has anyone ever camped on a mobile network rather, in-flight before? Made a call or sent a text message? So this is widely available now on the long-haul flights that you can, maybe you've done it with Wi-Fi. It's provided by the same people, by Panasonic. But you can actually register on our network in flight now and make calls backhauled over satellite. And we've been doing that for quite a long time. So verticals, there's a lot of verticals there, but I think the first one in the top left corner, medical, that's a key one. Because there's a lot of nomadic employees, as you can imagine. It's a large, wide campus area network. And they need mission-critical communications. So pagers are getting old, they're getting displaced. There's some really good nurse call technology out there now that can work on tablets and smartphones. But what good are they if the coverage underneath isn't resilient and doesn't ensure delivery of messages 100% of the time? So that's been a big vertical for us, both in elderly care and in hospitals. The same goes for the police and the security. They've been some of our early adopters. I don't know if you know, in the UK they're going to switch off the Tetra walkie-talkie network eventually. The plan was to do it by 2020 and run it on the public 4G networks. So some people believe that's one of the reasons that BT and EE were brought together, because they're expected to deliver on that tender. So in the meantime, we have partners delivering solutions to the fire services and the police services. If they have budget, they're buying our networks that they can fire up themselves, and they know when they arrive at an incident that they have guaranteed quality data and communication coverage. So it's been tried and tested in those kind of, in anger, as we say, in those kind of environments already. And then with marine, we deployed our first solution last year in the Dutch North Sea, so on an oil platform, which is very exciting. Emergency response, kind of touched on that already there with the police. Transport hubs. There's a lot of interference and congestion with data networks in transport hubs. So it's an ideal one. With IoT, public utilities are becoming very, very interesting for telemetry. Mining, industrial, we've been doing that for a long time because there's absolutely no coverage out there. So again, like the network in a plane, it's backhauled over satellite, and they have no communications whatsoever. Public offices, so as buildings advance, etc., and they get more energy efficient, they're just repelling more and more public network signals. So with Britannic, we're often solving these not spot issues. You've got great coverage of 4G when you walk outside your office, but what happens inside? So we can deploy a network inside a series of small cells that can solve that issue. And then defense and military, yeah, if there's any here, they normally have great budgets and they're interested in the latest technology, so they're often the first adopters for what we do with networks and drones or in backpacks. So let's go to the product side of things. So if we take a look at the evolution of mobile communications, so if we go back to the first network call, 1G, analog cellular, and that was made on an 11-pound Vodafone VT1. So if you were carrying that in your pocket, you'd be seen coming today. It lasted for 30 minutes, but very, very innovative at the time. And then with 2G, this is when we saw, you might recognize that handset, I certainly do, I'm old enough to remember having that one. That's when we saw the widespread adoption of mobile handsets and a little bit of data. So we had edge data. So you can do a little bit of browsing, but very, very small displays. Then with 3G, we had mobile broadband for the first time, really. 3 to 5 megs, depending on network congestion, etc. And then with 4G, obviously we started to see YouTube, Netflix, all of these video streaming type applications appearing, and they required far more data. So 4G delivered tenfold speeds. And then finally 5G, we've been testing 5G since last year with our partners, and people often ask me, what is it? Is it a radio? For us, for Druid, it's about more bandwidth, really. It's the next iteration of technology. And we're using 4G phones or 4G devices, but it's about even greater speeds than 4G. Because people often ask me, what's 5G all about? It's about more and more data speeds on cellular networks. So just to skip back a little bit there, I've just highlighted the guard band spectrum license. That was an auction in 2006 in the UK. There was 12 successful licensees. And at that point, Druid teamed up with one of them, FMS Solutions, and we signed our global OEM agreement with Mitel, and we started deploying mobile networks very, very quickly. So we don't need an operator to do that. We can deploy in the guard band spectrum today. Very, very clean spectrum. We'll go into that shortly. But we still think it's the best voice, messaging, and low bandwidth machine-to-machine IoT technology today. 4G is great. And that's bringing digital transformation, absolutely, and robotic process automation, real-time applications, etc. But still, for voice and messaging, 2G is a great technology. And we've test licenses since last year for 5G, for testing 5G. But that's, again, about more data speeds, greater data speeds, which is very exciting. So let's touch on Wi-Fi for a second, because we all use it. I think Wi-Fi is a great technology. But this will explain why private 4G works so well, too. I mean, if you fire up in the top left corner there, if you fire up an application like that at home or in a space like this, you're going to see a lot of Wi-Fi access points, a lot of SSIDs, a lot of co-channel interference. It's hard to avoid. I'm sure some people today may have fired up some hotspots with their phone, etc., when they needed to connect their laptop. A really good Wi-Fi network will be affected by that. So the fact that Wi-Fi is unlicensed is great. It means you can you do lots with it. But the fact that it's unlicensed means it can be easily congested as well. So if you don't know Wi-Fi well, I've put 2.4 and 5 gig up there, or you may know that well. Where we're deploying is in band 3. It sits in the middle at 1800 megahertz. So with Britannic, for example, we deployed with a manufacturer of theirs that was suffering with their Wi-Fi. It was their own Wi-Fi, but they were trying to run voice and all of their data requirements on that network. And with 2 picocells, we went in and layered in a 2G network that doesn't interfere with that Wi-Fi at all. It actually decongests their Wi-Fi and provides them with a guaranteed quality of voice on that network. So the private mobile stack. So we're deploying 2G and 4G networks in the guard band. And then you can layer voice on top of that natively. You can just make a native call like you'd expect to do on your mobile. Or with Britannic, we could deploy, like that use case I talked about, there's an Avaya application there. So they could use the Avaya app to make the call, should they want to, or a Mitel app. But we dedicate that voice. That's what Druid do. We dedicate the SIP bearers and the SIP channels from all of the other traffic. So that's how we guarantee the quality of the voice. And then you've got messaging, voice and presence on those applications. Then we have an open API. This is another reason we're very successful in hospitals and healthcare, that we can integrate to nurse call, the latest nurse call technologies. So the pagers aren't there anymore, and they're sending all of the nurse calls to the mobile handsets now. The same with retail, location, asset tracking, man down, lone worker applications. There's a whole ream of really interesting business process applications out there. And we can integrate those to the private network. And you can't do that with the public networks. And then finally, IoT. So with IoT, we've got Cat-M at the moment, which will support up to 500 IoT devices per small cell. And our small cells are about the size of a Wi-Fi access point. So that's very, very innovative. Where we're going very, very quickly, we're testing it already, is NB-IoT, stands for Narrowband IoT. That will be able to support up to 100,000 IoT devices. Myself and Ken were talking over dinner last night. We were like, where are all those devices going to come from? But the capability is really, really interesting. So what you're investing in today, I suppose, the message there is this is all at our doorstep. So we have a software-defined platform. I found a nice picture on the right-hand side of a base station controller from the 80s. Like, it's a comms cabinet in itself, but that is just the base station controller of an old GSM system. We don't even show the BSC, the base station controller, in our stack. If I was to highlight it, it would be in the RAN server section in the left, near the ABIS. That's where it would be. So the point I'm making is how we can scale things. We have all the rich attributes and features of a mobile network running on a laptop outside at the moment. And if you search on your phones, you'll see it'll be 23404. Or it'll say maybe Britannic. Did we put short network name Britannic in it, etc. But all that's running on a laptop outside at the moment. Or we've put them on Raspberry Pis in drones. Or normally 1U servers, industry standard 1U servers, or virtualized, etc. So the ability to be able to deploy like a small 10-user system or something that can handle 10 million calls in a hospital, as I said, it's very, very easy to execute. It's all been done in software. Let's focus on some solutions. So we've got enterprise communications, Internet of Things, and public safety. That's what we're going to focus on quickly. So we can be deployed on a LAN or a WAN. So we talked about that use case, that manufacturing facility, for example. So our application sits in the cloud in that particular scenario. That's what was required. And then we have an open SIP interface to the Avaya PBX. But it's an open SIP interface, so we don't really mind if that's Samsung, Avaya, Mitel, etc. And we turn your mobile device into a SIP extension of that PBX at that moment. So that's really good for internal communications. And then if anything happens to the PBX, you still got mobile calls happening. Then our open API will connect the alarm server or any type of business process application to it. And then we're deploying a number of these small cells, as I call them there. That's what's delivering the coverage, and we're enabling handsets, tablets, etc., any SIM-based device. And then, of course, because you're holding a cellular device in your hand, you often ask, well, what happens when I leave the building? So we can give you a roaming SIM where you can roam from the private to public network if you want. But in certain cases, like if you give the nursing staff in the hospitals devices, those devices will be controlled and managed at the enterprise. They'll be put in a charging bank at the end of the day, and they won't be leaving with the device, for example. But that flexibility is there. So if any IT managers here move from site to site, etc., there's poor in-building coverage wherever you go at the moment with the businesses you work in. You could put a small cell network into each of those buildings, and you'll seamlessly roam and have coverage where you didn't have it before. And then we're leveraging all of these great cellular devices that are out there. Like the yellow one there at the bottom and the one to the right of it, they're £25. It's an incredible difference from the proprietary Wi-Fi and DECT handset. And its capabilities. It has the uplink strength to travel miles to the nearest macro base station. That's how they've been built. But because they're being bought in their hundreds and millions, they're very, very cost effective. And then they're ruggedized, waterproof, etc., if they need to be. Or you can go more high-end, Samsung S8s, HTCs, Windows, and then, of course, Apple. And then there's a whole device ecosystem out there of conferencing, tablets, headsets, wearables. I have a Huawei watch on me here today. They're becoming very popular in care as well. They're putting alarm applications on the Android Wear platform and putting very robust wearables on people. The Pebble device in the center there, the little colorful devices, that's a panic alarm device. And that was one of the earliest use cases of roaming in the UK, where they wanted these for the residents in the assisted living areas of care villages. And they could take those devices down to the local Asda, Tesco, etc., and know that they had a panic alarm device on them. It has an accelerometer in it and gyroscope, so if they fall, it'll send off an alarm, and there's 4 predetermined numbers that it can get to. And what we do there in the care village is guarantee that there's coverage for those devices and integrate to the nurse call systems. So yeah, there's an example of a care village, but it could be a hospital campus, etc. You've got your care home in the center, and then these assisted living apartments around the outside. So I want to talk about the coverage advantage here. So when they were considering this particular site, which has now been deployed in Oxfordshire, they were looking at 140 decks minimum, 200 Wi-Fi at least, and there is Wi-Fi on that site, but they went in with 20 2G cellular base stations, for example, outdoor and indoor. So it's just much easier to deploy and execute, manage, etc. And in this scenario here, it's a manufacturer, a bakery. This one had 97 Mitel decked, and they were considering blanket Wi-Fi everywhere. And then just 15 small cells again, with some Wi-Fi hotspots. And that's a marriage of both the base station and the handset, giving you that kind of distance. Does anyone recognize this building? So that's one of our landmark sites in Manchester, the Midland Hotel. Very, very challenging environment. There's some of the walls in there are 3 meters thick. It's a really, really old building. That had about 160 ASCOM decked points in it, and the coverage, again, it was about coverage at the start. And we deployed 30 picocells inside the building. So hospitality is another really obvious vertical. You've got lots of nomadic employees, etc. IoT. So our IoT Reach application, we've got an oil rig here at the center for this example. So they would have been using Wi-Fi in this kind of environment up to now, but now we deploy just 4 high-powered 4G access points on the rigs. And they're connecting interesting things like 4G wireless cameras that have become available in the last 2 years. So there's no requirement for power or cabling, or you could power it. You have the option to do either. And their video is streaming. All it needs is a SIM in it. Body-worn cameras as well. And then push-to-talk. With what we're doing with the emergency services networks in the UK, that's all about push-to-talk over 4G. And it's an excellent technology for that, to be able to deliver that. So there's a natural migration from the old walkie-talkie two-way radio systems to 4G now as well. And then telemetry on the IoT side. And then we're managing all of the local data breakout on the rig itself, and we only backhaul over the microwave point-to-point link what needs to go back. Shipping. So 2G networks have been delivering IoT in shipping for the last 2 decades, and now moving to 4G very quickly. And once they leave shore, there is no mobile coverage out there. Again, like the example I gave you in flight, we backhaul over satellite quite easily in that scenario, and they're tracking where the containers are. If they're refrigerated containers, they're monitoring them, etc. And they're able to make calls. It's a much easier technology to deploy on the ship as well. Normally it just needs 1 high-powered base station on the deck. And then our IoT service provider. So this is about port automation and delivering 4G networks in the ports themselves. So we've got two case studies to look at quickly. In the top, we're looking at autonomous vehicles with Ericsson in Sweden, and we're working with Volvo and Scania trucks. It's a very, very exciting use case. So it's called ASTA0, which stands for Active Safety Test Area. And it's an initiative in Sweden to lower fatalities and injuries on the roads. So in that video clip there, you can see the trucks are basically running themselves with an application on our 4G networks. And towards the end of the couple of minutes there, they're actually testing brake technology. In the lower one, it's our industrial automation use case. And obviously, automation drives efficiencies with shipping companies. It's all about competitiveness. They've tried to do both of these use cases with Wi-Fi in the past, but they're large, wide area networks. Latency is an issue as well. Cost is an issue. And 4G technology is perfect for it. Public safety. So for public protection disaster relief areas in Asia Pacific, the Gulf of Mexico, etc., we have partners there that deploy container-sized networks, instant networks, for covering cities effectively. So when the total communication systems go down, they have an instant network available to them, and they can give out handsets in that kind of scenario. And then back to the UK for a second. Over the last couple of years, as I mentioned earlier, we're deploying with the first responders. And they've been putting our networks in Peli cases and in command vehicles. And then the first responders at the incident itself are wearing body-worn cameras, and they're providing real-time video and audio back to their commanders within a 2-kilometer area. Our next iteration of that will give us 5, even 7 kilometers. So the idea is here, when they turn up at an incident, they have their own dedicated network that can deliver this. And then patrol communications. So with this, we've been deploying with drones now. And then, handsets are so light, backpacks are so light, it's ideal, as you can imagine, for patrol. This is an example of a command vehicle we built with one of our UK partners in the first responder space. And you can see inside there, it's nicely kitted out like the A-Team van. They've got screens everywhere. Our graphic user interface is the one with the colorful donuts there inside. They can actually see how many users are on the network, how much data is happening. And you can see there's some video feed coming from the body-worn cameras outside on the stand, etc. So these were some of the early use cases a few years ago. Question and answer time. Any questions? Sure.
Just curious as to who, I mean, we've kind of seen various verticals that you serve. What's the difference between this and kind of standard M2 cells for commercial mobile providers? I mean, we have one of our offices, we have particular coverage problems in the city.
Yes.
And the answer was to get a M2 cell. That was it. So
that's a great example. That's a very similar solution architecture. But what we do is give you control. We call it a private network, but it's because it's your network. So Britannic deliver a network in that scenario that you can integrate with your PBX if you want to, but it's your network. You can add users, you can blacklist users, whereas you're not having to ring, let's say if it's a Vodafone femtocell solution, you're not calling them going, I've got problems with this. The cost of it as well, I would have thought it's more favorable. But it's your network. It's actually your network. And then if we go back to some of the examples here, I don't know, what is the environment? Is it just a general office? Just an office? So we could integrate with the PBX. But if there was any other type of business process application, our open API is there to integrate with that. That's why I mentioned hospitals, I suppose, and some obvious examples. But yeah, we give you control, full control, visibility, and speed, speed of just getting a handset up and running and working.
it sounds like it's for very large enterprises as well.
No, again, a very good question. So we have a lot of big customers. But with Cumbria County Council, for example, they took 3 systems, 10 users, 1 base station. Very, very small homes, I believe. But they were just able to put that picocell in the server room. They didn't even have to do any radio coverage planning. So very, very cost effective. Yeah, we were given a target price against DECT on that one. I think it was NEC DECT. And yeah, we're competitive. Us Irish people are competitive. Yes?
Covering, was it 10,000 IoT devices?
100,000. Yes, yes.
How readily do you see industries moving towards that? And in which areas do you see it happening?
So in the port automation story, there's hundreds of modems connected there already. So that I would consider that Cat-M. So yeah, it just depends on. I think in utilities, in a large utility, they'll just start adding more and more machines to the network. I think that's what's going to happen. And then with 5G is about greater bandwidth across all of the operators. So we'll have all of these various sites maybe on one core network running in a Britannic data center, for example. So 100,000 devices mightn't just be one site. It might be 2 or 3 sites. And then if you take it to the smart city side of things, you can see where they're going with this technology. 100,000 is small numbers when it comes to a citywide scenario. Thank you.